So page 2, exact values of angles. We're going to look at angles that are bigger than 90 degrees and how to approach those. So things like 120, things like 240, 300, 315, big things. Okay, most of the ideas remain the same. Just one little thing we have to add here. So we still draw our terminal arm in the correct position. So go around counterclockwise from 0. We still make a triangle with the x-axis. But now, when we make that triangle, if you look at this diagram here, we're going to use the acute angle inside the triangle to figure out which special triangle we're using. So even though we measured this principal angle out here, let's say this was 120 degrees and went around to there, we would actually use what's inside. So if that's 120, what's remaining over here, that's 180, this would have to be a 60. That will tell me which special triangle to use. Okay. Once we're done that, everything else remains the same. Special triangles, label your sides, okay, and then use your Sixerticks to figure out what the exact value of a ratio is. Okay, as we look at the first example here, cos of 315. So thinking about where numbers are, there's 0, there's 190, there's 180, there's 270, 315 would be all the way around to this quadrant down here. And there's my terminal arm. I want to make my axis, or sorry, my triangle with the x-axis. Okay. This is 0, but it's also 360, right? So if I've got 315 that I've gone through so far, I haven't gotten quite to 60. In fact, I'm 45 degrees short of 60. Yes, that would be the acute angle inside the triangle, if you will. If one of them's 45, the other one's 45. And that's one of our special triangles. The 45 one is one with the two ones and the root 2. Now be careful here. We've actually gone down the y-axis, so it needs to be negative. Okay, remember, x's and y's can be negatives, r's cannot. The cos ratio, x over r. So the cos of 315, okay, we use the x value from our triangle, that's a 1, and the r value from our triangle is a root 2. Right? So even though we use the 45 for our triangle, we're still actually answering the angle of 315. Okay, let's try the second one. Second one, we're looking at the sine of 240. So 240, where would that be? Here's 0, 90, 180, 270. So 240's got to be in here somewhere, right? Okay, in fact, 240 will be all the way around to there. I've gone past 180, but not quite to 270. How much past 180 have I gone? Well, it's 60 degrees past 180. If that's 60 and this is 90, the third one has to be 30. And the nice thing about 30s is root 3's go beside them. And because we've gone down the axis, it needs to be a negative. Remember, we have a 3, a 2, and a 1. It's a regular 2 because we've already done the root sign. And the 1 has to be negative because we've gone to the left. Okay. Sine ratio is y over r. From our diagram, the y value is negative root 3, and the r value is 2. So the sine of 240 is root 3, or negative root 3, over 2. And if you want to give the last one a try, that would be a good time to do that. Tan of 150. Tan of 150, if we draw that out, 150.
Miss McWhorter, I have a call for you on line 801. Miss McWhorter, line 801, please.
150 would be right about here, because that's 150, and we know this is 90, and this is 180. Hey, we haven't quite got to 180. In fact, we are 30 degrees short of it. Oh, 30, we like those ones, right? Because we know 30s and root 3's go beside each other. To the left, so it's negative. 3, 2, 1. Okay, tan is ticks, y over x. So our y value is 1, and our x value is negative root 3. And there's the tan of 150. And we can do these for any angles that are combinations of 30s or 60s or 45s or multiples of those. Okay, the ideas don't change. You just have to draw them in different spots. Hey, our last idea. We got a couple special cases where SOHCAHTOA wouldn't work. The whole idea of Sixerticks is to deal with these ones where SOHCAHTOA won't work. Okay. The ones that don't work are ones that land on the axes, on the 0, the 90, the 180, the 270, because you can't really draw a triangle. If I look at the first one here, sine of 180, just to draw it out, I'll move it down a little bit here. Okay. 180 would be right here. Well, how can you draw a triangle when you're on the line already, right? So we've got a problem here. So anytime we come across ones that deal with 90s or 0 or 180 or 270, we have to approach this in a slightly different way. We still want to think of this as rotational, like a circle. But we're going to pick the easiest possible circle we can, the unit circle, a radius of 1. Because then we can actually figure out the coordinates of all these dots. If our radius is 1, if it from here to there is 1, well then that has to be 1, that has to be 1, that has to be 1, and this has to be 1, right? So we can actually label these as coordinates. This point over here would be 1 and 0. Then one up the top would be 0 and 1. To the left would be negative 1 and 0. And down below here would be 0 and negative 1. And remember, points are made up of x's and y's. And since we have r's and we have points, we can figure out the ratio really quickly for anything. Sine of 180, sine y over r. Here's 180 right here. Okay, the y value is 0. The r value, we said radius of 1. So there you go. Sine of 180 is 0. The tan of 270. Tan of 270, that's tex, y over x. From tan, y is negative 1, x is 0. If you actually try to do that with your calculator, it says error. Okay, we call that undefined. Okay? It doesn't exist. So if you ever come across the word undefined, that just means you have a 0 on the bottom. And if you tried cos of 0 is x over r. So for our answer, 0, we already looked at the first one here. X is 1, and r is 1. And 1 divided by 1 is 1. Okay, and that's how you can find the exact value of anything that deals with 30s, 45s, 60s, including the special ones that land on the axes. Okay, no special triangles there, just circles. So give this homework a try. Lots of practice with these little things, and maybe try the quiz tonight also. Probably a good idea.